The ores are extracted from the earth through mining. They are then refined to extract the valuable element, or elements. The grade or concentration of an ore mineral, or metal, as well as its form of occurrence, will directly affect the costs associated with mining the ore. The cost of extraction must thus be weighed against the metal value contained in the rock to determine what ore can be processed and what ore is of too low a grade to be worth mining. Metal ores are generally oxides, sulfides, silicates, or native metals that are not commonly concentrated in the Earth's crust, or noble metals such as gold. The ores must be processed to extract the metals of interest from the waste rock and from the ore minerals. Ore bodies are formed by a variety of geological processes. The process of ore formation is called oregenesis. Ore deposits. An ore deposit is an accumulation of ore. This is distinct from a mineral resource as defined by the mineral resource classification criteria. An ore deposit is one occurrence of a particular ore type. Most ore deposits are named according to their location, or after a discoverer, or after some whimsy, a historical figure, a prominent person, something from mythology, or the code name of the resource company which found it. Classification ore deposits are classified according to various criteria developed via the study of economic geology, or oregenesis. The classifications below are typical. Hydrothermal epigenetic deposits, mesothermal lode gold deposits, typified by the Golden Mile, Kalgoorlie. Archean conglomerate-hosted gold-uranium deposits, typified by Elliott Lake, Canada and Witwatersrand, South Africa. Carlin-type gold deposits, including epithermal stockwork vein deposits. Granite-related hydrothermal IOCG or iron oxide copper-gold deposits, typified by the supergiant Olympic Dam CuOU deposit. Porphyry copper plus or minus gold plus or minus molybdenum plus or minus silver deposits. Intrusive related copper-gold plus or minus, typified by the Tombstone, Arizona deposits. Hydromagmatic magnetite iron ore deposits and skarns. Skarn ore deposits of copper, lead, zinc, tungsten, etc. Magmatic deposits, magmatic nickel copper iron PGE deposits including cumulate vanadiferous or platinum-bearing magnetite or chromite cumulate. Hard rock titanium deposits, comatite-hosted Ni-Cu-PGE deposits, subvolcanic feeder subtype. Typified by Norrells Talnak and the Thompson Belt, Canada. Intrusive related Ni-Cu-PGE, typified by Voisey's Bay, Canada and Jinchuan, China. Lateritic nickel ore deposits, examples include Goroanacolia and Ravensthorpe, Western Australia. Volcanic-related deposits, volcanic-hosted massive sulfides CuPb zinc including, examples include Teutonic Bore and Golden Grove. Western Australia Beshi-type, Puraco-type. Metamorphically reworked deposits, podiform serpentinite-hosted paramagmatic iron oxide chromite deposits, typified by Savage River, Tasmania iron ore, Kubana chromite deposit. Broken Hill-type Pb zinc Ag, considered to be a class of reworked SEDEX deposits. Carbonatite alkaline igneous-related phosphorus tantalite vermiculite. Rare earth elements, Mount Weld, Australia and Bayanobo, Mongolia. Diatreme-hosted diamond and kimberlite, lamproite or lamprophire. Sedimentary deposits, banded iron formation iron ore deposits, including channel iron deposits or pisolite-type iron ore. Heavy mineral sands ore deposits and other sand dune-hosted deposits. Alluvial gold, diamond, tin, platinum or black sand deposits. Alluvial oxide zinc deposit type. Sole example, Scorpion zinc. Sedimentary hydrothermal deposits SEDEX lead zinc silver, typified by Red Dog, MacArthur River, Mount Isa, etc. Stratiform Marcos-hosted and shale-hosted copper, typified by the Zambian Copper Belt. Stratiform tungsten, typified by the Erzgebirge deposits. Czechoslovakia exhalative spilite chert-hosted gold deposits. Mississippi Valley-type zinc lead deposits. Hematite iron ore deposits of altered banded iron formation. Astroblema-related ores Sudbury Basin nickel and copper, Ontario, Canada. Extraction. The basic extraction of ore deposits follows these steps. Prospecting or exploration to find and then define the extent and value of ore where it is located. Conduct resource estimation to mathematically estimate the size and grade of the deposit. Conduct a pre-feasibility study to determine the theoretical economics of the ore deposit. This identifies, early on, whether further investment in estimation and engineering studies is warranted and identifies key risks and areas for further work. Conduct a feasibility study to evaluate the financial viability, technical and financial risks and robustness of the project and make a decision as whether to develop or walk away from a proposed mine project. This includes mine planning to evaluate the economically recoverable portion of the deposit, the metallurgy and ore recoverability, marketability and payability of the ore concentrates, engineering, milling and infrastructure costs, finance and equity requirements, and a cradle-to-grave analysis of the possible mine, from the initial excavation all the way through to reclamation, development to create access to an ore body, and building of mine plant and equipment, the operation of the mine in an active sense, reclamation to make land where a mine had been suitable for future use, trade. Ores are traded internationally and comprise a sizable portion of international trade in raw materials both in value and volume. This is because the worldwide distribution of ores is unequal and dislocated from locations of peak demand and from smelting infrastructure. Most base metals are traded internationally on the London Metal Exchange, with smaller stockpiles and metals exchanges monitored by the COMEX and NYMEX exchanges in the United States and the Shanghai Futures Exchange in China. Iron ore is traded between customer and producer, though various benchmark prices are set quarterly between the major mining conglomerates and the major consumers, and this sets the stage for smaller participants. Other, lesser, commodities do not have international clearing houses and benchmark prices, with most prices negotiated between suppliers and customers one-on-one. This generally makes determining the price of ores of this nature opaque and difficult. Such metals include lithium, niobium, tantalum, bismuth, antimony and rare earths. Most of these commodities are also dominated by one or two major suppliers with greater than 60% of the world's reserves. The London Metal Exchange aims to add uranium to its list of metals on warrant. The World Bank reports that China was the top importer of ores and metals in 2005, followed by the USA and Japan. Important ore minerals: acanthite, Ag2S for production of silver, barite, Basa-4, bauxite Al3 and Alu, dried to Al2O3 for production of aluminium, beryl, B3Al26, bornite, Cu5 Fes4, cossiterite, SNO2, chalcocite, Cu2S for production of copper, chalcopyrite, Cufis2, chromite, Cr2O4 for production of chromium, cinnabar, HGS for production of mercury, cobaltite, As, columbite, tantalite or coltan, 206, dolomite, CAMG2, galena, PBS, native gold, O, typically associated with quartz or as placer deposits, hematite, Fe2O3, ilmenite, Fe3, magnetite, Fe3O4, malachite, Cu2CO32, molybdenite, MOS2, pentlandite, 9S8, pyrolusite, MnO2, scheelite, coro4, sperrylite, PTAs2 for production of platinum, sphalerite, ZNS, uraninite, UO2 for production of metallic uranium, wolframite, WO4,